Hello everybody. Welcome to this talk about JSON. JSON is a popular format for storing semi-structured data, not only for storing but also for transferring semi-structured data over HTTP, HTTPS and so on. Today we will use it for storing data in a relational database. I remember a project. So first of all, okay, I will open the other chat. You can ask questions in the chats. Say hello, so that I know that you are there, that you can hear me, and then I will start telling my story. Okay. The chat is opened now. Ask questions during the talk. Yeah. Okay. Welcome. Cool. There was a project of a web application that should be customizable. I don't know what this customizable thing always is about, but this is often required, and I often say take a look at Apple. Apple products are not so customizable in my opinion. I don't use Mac, I don't use iPhone, I don't use Apple products because I want to configure my applications and my devices as I want, but Apple is a good example for let the people use the application as they want. And there was this, it was an online banking system where the users, after they log in, can configure how their dashboard should look like. So they could configure, okay, I want my current account state here. How much money do I have on my account? I want this here. Others want this at the bottom. Then you could configure that here's a list of the transactions, and this list should contain the last 3 days. Other users configure this list of transactions of the last 10 transactions. So the idea was that a banking user could configure the look and feel of the application like they want. A customizable GUI. And when you say, this thing here that shows me some bar charts and so on, I don't need this anymore, then you press an X and reconfigure your dashboard, and this should be stored somewhere. So this was now where I came into place, how to store this in a database. And then the first idea from the software developer was, okay, we have an entity user. Let's not draw it like let's draw it like an entity relationship. A user has a user ID. A user has email and other properties like password, name, country, city, and so on. So this is the user. A user has multiple accounts, but that's not important for now. And then a user has one window. And this window contains of so-called panes. So a pane is what is on top, what is on the bottom, what is on the left and the right. And on each pane there is an element. And elements do have subtypes of buttons and so on. And then I said, okay, this took you a whole week or so to model the whole database. I have another idea. GUI. Just store everything about this GUI in a JSON in one attribute. That's it. You don't need tables, foreign keys for simply storing something that you never query. Nobody will query, how many users have their account list on the bottom right. Nobody wants to know that. This is just an attribute where you read the current configuration, then tell the application to draw the look and feel, and then you then you work with it. And when you reconfigure it, you change something here. So simply, this is an integer, this is a varchar, and this is a JSON. And that's possible with most relational database systems nowadays, even if it would not be possible, even if you use, is there a relational database system with no JSON support? There are, of course. I don't know if SQLite has JSON support, but let's say there's a database system without JSON support. Then you simply store the JSON data in a varchar column, because you just store it there and you retrieve it. That's it. We will use PostgreSQL today because PostgreSQL has a JSON data type, and let's select 5 is my favorite query to check whether I'm connected or not. Yes, I'm connected. There's a JSON data type. So first of all, I create a new schema, create schema lecture 20, because today is the 20th of April, and then set search path to lecture 20. This means when I create a table, it is stored in that schema called lecture 20. When I write a select or insert query, it selects it from the tables from this schema. Okay, now I can create a table. Let's call it create table users for the online banking users. A user has a user ID. Let's use serial. This is an alias for integer in PostgreSQL, but when you use serial, you a sequence is automatically generated so that PostgreSQL will automatically write 1, 2, 3. It's basically an auto increment. Then you have a name. Let's say 100 is sufficient. And then PostgreSQL supports 2 types for JSON. One is called JSON and one is called JSONB. JSON actually stores the data as a text, and JSONB stores the data in a binary optimized form. We saw how binary JSON can look like internally in another lecture. It is optimized for faster search, because searching a string which has double quote characters, commas, colons, and so on, you have to search the full string, every character from the first byte to the last byte to find something, even if you don't find anything. And if it's internally stored as a BSON, or BSON is binary JSON, PostgreSQL calls it JSONB, then it's betterly stored internally. Not more compact, so it doesn't consume less space or more space or so, but it's for faster search. Let's start with JSON. So now we can say insert into users. We don't need to specify the user ID because it's automatically generated serial number and the GUI, and let's say the person is called Peter, and here I say something. Error, invalid input syntax for JSON. This is invalid. So you see, it checks for well-formedness. So this is not a valid JSON, a well-formed JSON document. So you must insert something which is a valid JSON document. So let's say A is 5. Okay, this is now possible. And we will today look at how to work with data that is stored in a JSON format within such a JSON column or a JSONB column. We will take a look at other database systems, database management systems, not only PostgreSQL, how they solve this, and we will take a look at how to query the data that is in JSON fields, how to transform JSON data into native columns, because that's a very good approach. Querying JSON is not as performant as querying native columns, of course. When I say give me people whose first name start with a P, that's easy. Where name like P%. Databases are optimized for these kinds of queries. When I say give me all people where the GUI has an A attribute which is between 5 and 8, yeah, this is more complex. So one approach is, if you need such a value very, very, very often, make a native column out of it. So your task is choose which columns you need as real columns. For example, we could say the user does not need a name. We simply put the name here. Name is Peter. So user does not need a name. But then it is more costly to query. So we will take a look on how to transform JSON data into columns. And we will look at the other direction, how to transform column data into JSON data, how to build JSON. And we will take a look at index support for JSON data. Because when you say, no, I need it here, I cannot move it in a native name column, but I want to accelerate queries, give me the people where name is Peter, or give me the people where A is between 5 and 10, then it's possible to create an index on the fields that are within the JSON data or on the whole JSON document itself. Because one benefit of JSON is you are very flexible. Other documents, other rows in the table can have other fields, other attributes. They can have sub-attributes here. They can have arrays. So one benefit of using JSON is flexibility. And the second benefit is you have arrays, you have sub-attributes, so you have everything for storing compound data, complex data, not only literal values, not only storing scalar values here. So you're schema flexible, and you have arrays and lists and so on. And another benefit is you can immediately start inserting data, because you don't need to create so many tables and think of which attributes do I need and which don't I need. Simply put the data there as it is. So basically what we have here is a kind of NoSQL database now, because MongoDB stores JSON documents, and now we have not MongoDB but PostgreSQL, and we can simply also store JSON documents, and we can use a query language to query that data. Okay, let's start. In 2016, the JSON support was introduced in the SQL standard. Actually, the SQL standard was a bit slow. There were already databases with JSON support before 2016. And then the SQL standard said, okay, we need to put this in the standard. This is not specified yet. And so it came into the standard 2016. Part of the standard is a JSON data type. So what we saw in the create table, we can say this column is of type JSON. We have mappings. So how to map JSON data to column values or to values of the built-in data types. So how to access the JSON data that's stored in that column. And the other direction of mapping is how to build JSON. So how to convert a varchar or multiple varchars into a JSON array, for example. The JSON standard introduced predicates for checking whether something is found within the JSON or not, or it supports path expressions, JSON path, and it supports functions, for example, a function to remove an attribute from this JSON, or a function to retrieve a specific value within this JSON document, within this JSON array, or whatever this is. Okay, what we have here is now a table called people. For trying this out, I use Oracle because Oracle is close to the SQL standard here. PostgreSQL again does it a bit differently. Yeah, this is the same for all databases because there's a JSON data type. Okay, in PostgreSQL you can also use JSONB. And the SQL standard introduces, for example, the function called JSON value. It takes two arguments. First of all, the field where the JSON data is stored. So in our case, the hobbies column, and we store a JSON array there. We could also store a document, an object, whatever there. And then a path expression. This is JSON path. Path expressions typically start with a $, which stands for the root of the JSON document. In our case, the JSON document is not a document, but an array. So we can access the first element in the array with box brackets 1. Okay, so this will give you from our people table for each person their first hobby. So in Peter's case, the piano. For a predicate, we see an example here, JSON exists. Again, the first argument is the JSON data, which is in our column hobbies. And the second argument is again a path expression. So this is a path expression that is evaluated on the data. So for example, we take a look at the root. This is an array. Then we go into the array elements that fulfill the given predicate. Question mark is always a predicate. And the predicate is the current element which we are looking at. So in the first iteration it's piano. The second iteration it's yoga. There we find all elements in the array that are equal to yoga. Yeah, this is not so interesting what the result is. It's only interesting, is there a match? Is there something found, yes or no? If yes, then JSON exists returns true. So if this path expression matches at least once, so does it return at least one thing? If yes, then it is true. If not, then it is not true. Okay, let's take a look. These are exactly those commands. Create table people, hobbies. Yeah, here I don't use JSON because Oracle does not have a built-in JSON type, but Oracle has functions to work with JSON data that is stored in varchar columns, character large object columns, and so on. So Oracle says if you want to work with JSON data, use a varchar or character large object and store your JSON data there. And to avoid that arbitrary invalid, this is not invalid, but if I would remove this double quote here, to avoid that non-well-formed documents are stored here, the best practice is to use a check constraint. Check hobbies is JSON. So this is JSON is also part of the SQL standard. It is like is null or something. It checks whether it is a well-formed JSON or not. So with this check constraint, I avoid that somebody can store invalid JSON data within this column. That makes absolutely sense. So now I can store this document because it is well-formed. Okay, give me the first hobby. Okay, it is yoga. Oh, it is starting with a 0. That's dangerous when some systems start with a 0 and some start with a 1. But no, I think it is like in JavaScript. The first element of an array is the 0th element. So like opening a JavaScript console, A is an array consisting of hello and hi, and a 0 is hello and a 1 is hi. Okay, JSON uses starts with 0. Okay. Okay, then I get the first hobby, or in this case the second one. And this JSON exists here is a query where you filter directly on the JSON side. So this is executed on the JSON, and all that is sent back to SQL is true or false. Does it return something or not? And this is the approach you should always do. Do every filtering and so on as close as possible to the data. So I could think of another query, let's say, who has a piano as their very first hobby? Let's say this is an ordered list and the first one there is the main hobby of a person. So I could now do it like this. Select star from people, where, and now I get the first hobby of a person. So this is now the first one, is equal to piano. It finds our person Peter because, I access the array, go into the first element, it finds piano and checks whether, so this function here returns a text value piano. And now SQL, in this case Oracle, checks whether piano equals piano. And yes, this is the case. So this row is returned. But it would be better to make this predicate closer to the JSON data, earlier. Make this check earlier, because this is a waste of transforming and a waste of memory and a waste of comparisons and so on. Let's say another person has Jane has tennis and yoga. She's not found here, but nevertheless the first hobby of Jane is again returned by this function, and then Oracle checks whether tennis equals piano. This is not the case. So it is cheaper to check within a path expression. So let's say go into the array and go into the first element. How to, so I go into the first element. Let's try it out. So I go into the first element. The stupid thing on path expressions is when you don't have nested elements, how to access the current one. So this checks whether yoga is part of the array. So it iterates every one and no. Does somebody have a solution in the chat? This is a very stupid example where I cannot give a path expression that matches. I want to check whether this is the first one. So I need a path expression to find the position. Okay, let's skip this. But I will show you a solution later. The idea is always to check predicates if you can. So this would now be a solution because I don't know how to do it directly in JSON path. But if you know how to do a predicate directly in JSON path, then do it in JSON path, because first of all, it's more performant. And secondly, if we will later create indexes on the JSON data, the indexes cannot be used for these kinds of queries here, but indexes can be used for path expressions. Again, depending on the index. If you create an index on the result of this expression here, then this here will be used. We take a look at this later. Okay, I don't know how to do this path expression here now to check whether the first hobby is yoga. Okay, different vendors of database management systems implement the JSON support differently. So one approach is using a real native JSON type. This stores the data binary as binary JSON. So there was this slide on the JSON lecture where we saw, okay, when we have a document with these two attributes, ID and description, it is internally stored as, okay, the whole document has 45 bytes. This makes it easy to skip the whole document and jump to the next one if there's a next one. Okay, in our case, there is no next one in the column. And then for each attribute, for each field, we have a type of that field. 16 is number, and 2 is a string, and then we have the field name and the field value, and then the next field, and so on. So this makes it easy to skip long varchar fields, to skip long objects and arrays, to faster evaluate queries on the data. So some database management systems implement a native JSON type. So here the data is stored in a binary format. PostgreSQL added this in a version some years ago, calling it the JSONB type. And there are some functions which work on JSON and JSONB. There are some functions which only are supported on the JSONB type. The index supports only supports JSONB, and so on. So I would recommend to you to use JSONB when you work with PostgreSQL and JSON data because of its efficiency, and more functions and indexes are supported for these columns. JSON, so I come to the next. JSON as an alias for a string type. In PostgreSQL it is called JSON. So actually when you say this column is of type JSON, it is stored as a varchar, as a text. This makes it fast for inserting. So when you only need the example that I had here, a big JSON document describing how the GUI of an online banking system should look like, you'd simply put a large JSON value there, then JSON is fine. It's stored as a string, and there's a solution in the chat. I will take a look in a minute. Thank you. You store the whole JSON as a string, and then when you need it, you read the full string. Then JSON is fine. And in all other cases, when you really want to query the JSON data, or give me all people that have the a line chart diagram at the bottom right or something, if you want to write queries in the JSON, then use JSONB. And if you need index support, then use JSONB. But that's only true for PostgreSQL. In other database management systems, you unfortunately don't have the choice. In MySQL, you have a native JSON type. And as you may know, MariaDB is a fork of MySQL, which is completely open source. MySQL belongs to Oracle, but is also open source, but MariaDB doesn't belong to Oracle. And MariaDB wants to be compatible with MySQL. So every application that connects to a MySQL database should simply work even if there's no MySQL behind anymore, but the MariaDB. So the drivers are the same, the syntax, semantics, and everything should be compatible. MariaDB does not introduce a native JSON type, but for being compatible to MySQL, they simply introduced an alias for long text, which is called JSON. So when you say in a MariaDB, here GUI is JSON, then it's actually long text. Yeah. Then somebody can insert JSON data there, and as MariaDB also implements the functions on that data, it's compatible. But it's not so fast because MariaDB does not natively store the JSON data. Maybe in a future version. SQLite, okay, in SQLite everything is an alias for long text. No. When you say in SQLite, I want a column of type JSON, it is again stored as text. And to complete this list of alternatives here are database systems that don't have a JSON type at all. so that you manually need to store your JSON data into a varchar or character large object or binary large object column. DB2 uses blob, so binary large objects, and it makes a native storage there. So DB2 stores the JSON data like MySQL and PostgreSQL in an optimized storage format, but you need to specify a column of type blob for that. And Microsoft SQL Server and Oracle simply stores the JSON string in a text column. So then let's go back to our Oracle example here, and in this chat there was a solution. I try it out. I wanted to know who has the first hobby piano. Aha, of course. Yeah. How did I do it? So you go into the first element, and then, so this would return piano, or for the other person it would return tennis, and then after that you check whether this is equal to piano. Thank you very much. This is a solution. So these queries here are basically equivalent. This gives me the first hobby of a first person. So JSON path gives you back the first hobby of a person, and then Oracle checks whether this is piano or not. And this here, JSON path checks whether the first hobby of a person is piano, so it gives back true or false, and Oracle doesn't have to do anything anymore. So this is faster, and yeah, maybe an index could be used, maybe not. So this is not not the case for all queries. We have to look on this index usage later, because especially on Oracle. Thank you very much for this solution. This is very nice that things where I don't find a solution, that somebody else tells it. This makes more sense than that I Google half an hour here during the talk. Very good. There's a question in the other chat. Let me simply post it here. Will it return null or nothing if the array is empty? This is a very good question. If you use JSON value and there is no 0th element, or in our other example, if I say give me the A value, but there is no field A, does it return null or does it show an error? And this is what we had last time, what we call the lax mode. Lax is the opposite is the strict mode. You can configure each JSON SQL JSON query as lax or strict. Lax will give you null if nothing is found. Strict gives you an error if nothing is found. We will try this out later on PostgreSQL, but we have not yet made a query on PostgreSQL, so we will do this later. Very good question. Okay. Yeah, these are the three alternatives of how different database management systems implement JSON. How they implement JSON storage internally. They all on this picture here have JSON functions. So even if the data is stored as a string, it is possible that to query it with built-in functions. And let's say a database system would not support JSON functions. So let's say Oracle did not implement JSON, and they say simply store the data in a CLOP or a varchar. Then some smart user like you would say create function JSON value. So you could implement it by your own, because database management systems allow user-defined functions. So if Oracle wouldn't implement it by their own, then very quickly a user would implement it and then post the create function code on GitHub or so that everybody copies and pastes it to the database, and then you have the JSON value and JSON path exist and so on. But of course, not the users contributed to this, maybe if it is open source, but it is natively built in, so you can use the functions after you install such a database management system. In the database management system Exosol, that is the company where I worked before I became a professor, there is no built-in JSON type and no built-in JSON functions yet. It is currently under development. It is almost finished, I think. And but nevertheless, you can Google Exosol JSON. Oh, I think it's finished. JSON value. Oh, it is now released in Exosol 7. Yes, Exosol 7 has a JSON support. So JSON value, you put your JSON column in this expression, and then the JSON path expression here, and here's the JSON column, and then $.name. Okay, but in Exosol 6 this was not yet implemented, and then you need a workaround. Yeah, yeah, this is now a workaround. JSON value, so create script JSON value. It takes the JSON data as an input and the path expressions, and returns the result of that path expression on that JSON data. And in the background, it uses Python to import JSON and to access the path, and somewhere it returns the result of the path expression. So this was a workaround for Exosol version 6 to access JSON data with a JSON value function, even if this JSON value is not implemented. Now it is implemented and you can use it. And for the other database management systems, Oracle, DB2 and so on, they also implemented it. So for PostgreSQL, we have the JSON type. It stores the data as strings. This was introduced in 2012 in PostgreSQL 9.2. And 2 years later, in PostgreSQL 9.4, the JSONB data type was introduced. So in the first years, also there, JSON was stored as a string, and you could query that string data. Now with JSONB, you can query it in binary data. The B stands for yeah, it is not written somewhere. Some people say it stands for JSON binary and other people say it stands for JSON better. So better storage in JSONB. JSON is stored as a string. The benefit is if you insert JSON data, it's just inserted as it is. This is very fast. Here, when you insert data in a JSONB, it is first of all parsed and then stored in a binary format. So storing is a bit slower for JSONB columns, and for JSON it's faster. JSON and JSONB checks for well-formedness. So that's something we saw on Oracle. If we have our Oracle table here and we don't use this check constraint, yeah, of course, this is a CLOP now. Everything works as before, but but you could write invalid JSON data here. It works, but when you then make a query, let's make it even more broken. Okay, yeah, this is maybe the Lux mode. It does not show an error because this does not return anything. This JSON is not well formed, so every query will then return an empty result or will return a null value here, every function on that data. But to avoid this, to use always a check constraint to guarantee that each value stored in this column is actually a well-formed JSON. In PostgreSQL, when you use JSON or JSONB, you can only store well-formed data. So both types check for well-formedness. Another difference between JSON and JSONB is the white space preserving and so on. So if you store a JSON document in JSON, it is stored as a string as it is. So here we have our users. So let's again truncate table users. So it is empty again. And even if I use here after the colon multiple spaces, and here I make a second A, so this is not allowed in JSON. The keys are a key set, so it is not possible to make one and the same key multiple times. Let's try it out. The name column and then the JSON value. Okay. When I now say select star from users, we find it I copy and paste it to see, yes, the white spaces are there as we wrote them here, and the duplicate keys are here. It is prettified here, so this is not a feature of PostgreSQL. This pretty view here and showing it like this here is a feature of dbeaver, this client. The client will remove the white spaces and also removes the duplicate keys. But internally in PostgreSQL, it is stored as a string as we wrote it here. Now I drop the table and use JSONB. Insert the same user again. Relation user already exists. Insert. The column name does not exist. So drop table, create the table, insert the user, This is nice in dbeaver. I simply press Ctrl Enter on each command. No copy pasting necessary, no commenting and so on. dbeaver is so nice. Okay, now first of all we see a different order here. A is 6 and name is Peter, even if we wrote first name and then A. The order of fields in JSON does not matter, and in the binary format it's stored alphabetically, because this makes it easier for searching. If I say give me all people with age greater 20, then it can check, okay, A is 6, name is Peter, and age is between A and name, A and N, there between is the key age. So if there are 100 other attributes after the name attribute, then I can simply skip them because it's alphabetically ordered. So the order of attributes is not preserved here. The white spaces are gone and the duplicate key is gone. So it's basically overwritten that A is 6 now and not 5. So it overwrites the value. Typically this is not a problem. But if you want the JSON as it is, then don't use JSONB, then use JSON. Yeah, JSONB supports indexes. We will see this later. The native JSON data type only accepts well-formed JSON documents. We saw this in PostgreSQL. When you use JSON or JSONB, it's only possible to store well-formed JSON data here. This will give you an exception because the box bracket is missing here. Invalid input syntax of type JSON, the input string ended unexpectedly. It requires a box bracket, a closing one here. In other database management systems, we saw this on Oracle, you can use a check constraint. Oracle uses the SQL standard syntax. Hobbies is JSON. This is a predicate to check whether something is a well-formed JSON or not. In MariaDB, there's a function for that. So JSON valid. Does PostgreSQL has something like this? No. Does PostgreSQL have is JSON? No. So in PostgreSQL we don't need this because it automatically checks for well-formed. Here the best practice is to use a check constraint to only allow inserting data in that hobbies column that is a well-formed JSON. Like you use a check constraint to only allow email addresses with an @ character. Check email like %@ and so on. Here we check whether it is well-formed or not. There are functions to build JSON. Let's say we have no JSON. So this table here has no JSON yet. I remove this lux and strict. I will come to this at the very end of today's talk. Building JSON means you have data and you want JSON. In these examples here, we have JSON and we want data. So here we have data and we want JSON. Why ever? Because you import them and then you want to store them in a JSON format or something else. So there are functions to do that. Here's a cities table, here's a districts table to say, okay, Regensburg has so many inhabitants, Berlin has some more, and Regensburg and Berlin have multiple districts. So this is an 1-to-n relationship. Each city has n districts, and each district belongs to exactly one city. Let's store this information as JSON. I join the two tables, cities and districts. On city is city and district is district. The JSONB build object is a function that takes arbitrary many parameters, and you pairwise put a field name, the value of that field, next field name, value on that field. So we can simply try it out. Select JSONB build object, a field name, name, and then a value Peter, and then field name age, and then 5. Okay, it builds us just such a JSON document here. And if you want to say the age is not 5, but the age is again an object with a is 5 or something, then you can of course also nest these. So here Peter is a string, and here we put another JSONB value here. Okay, we do this for the city document. So we say our new document should have the field city, and we put in the value of the city column. Our new document should have a field population. We put in the value of the population column, and we want another field with the name districts, and the value there should use an aggregation function. So you know aggregation functions like sum, min, max, average, and so on. You use them together with a group by, and here we group by city and population, so that every city is not there as often as it has districts, but that each city is only there once. Basically, grouping by the city would be sufficient, but we need the column population here, and simply put everything in the group by that you need in the select clause that's not appearing in a aggregation function. So we group also by the population. And our aggregation function takes the set of districts. So for the row Regensburg 153094, it takes a set of two districts, Galgenberg and Kumpfmühl, and for Berlin it puts this one value in an array. So this produces out of a list of, in our case, varchars, a JSON document, a JSON array consisting of those values. So the result looks like this. For each city, we generate a JSON document, and the district is now an array containing the data here. So JSONB is an aggregation function. When we have a table, like our users table here, we can say select the name, then it produces an array with all names in our table. If we would have a second person as well, Jane has an empty JSON document here. So now we have two users. Then a query with an aggregation function that has not a group by always produces one row, and this row now has the JSON array with the collected data. So these two functions are two examples for functions where you can generate JSON data. Okay, now it becomes a bit weird because PostgreSQL does not implement accessing JSONs like we saw on the Oracle example. Oh, it's gone now. here it was. In Oracle and the JSON and the SQL standard, we use JSON value. Same here in the Exosol documentation, we use JSON value to access one scalar value that we find via a path expression. We put in the JSON and the path expression, and the result is the value that we find there. In PostgreSQL, they introduced a lot of operator symbols. This is very nice if you know them, but if they are new to you, this can be confusing. Oh, do you need one of these characters or two? When do you need that one? And when do you use a question mark and so on? So let's look at these operators in some detail. Okay, first of all, the ones which double a character here produce scalar data types. So the result here is not JSON, and here also not JSON. It is a text. So when we say give me the nth element of an array, like here, give me the hobbies 0, as we use the double what is this called, triangle here, the double arrow, it returns a text. If you use only one arrow symbol, then the result is JSON. This is good when you're not finished yet. So for example, we go into the profile, go into hobbies, profile is JSON, or profile is JSONB. The result of that, so these operators work on JSON and on JSONB data, the result of that is now a JSON array that we find in the field hobbies. Here's our JSON data. It has multiple fields, city and hobbies. So the result here is the JSON data that we find in hobbies. So what I marked here now finds this part. And now this is still JSON, so we can continue here. We can then access the next field. In this case, it's an array, so we can access now the second element of the array. And with this query, we can get the first element in the hobbies array for all people. So when you use such a double right arrow here, or double greater than symbol, then we are finished. Then we have no JSON anymore. You cannot continue after that. So this is JSON, the result of that is JSON, and the result of that is then a text. So it makes sense to, at the very end, use a double arrow to not have JSON in the result, because in the result it's often good to have a native data type of PostgreSQL, a good old data type of PostgreSQL. So we both use the arrows for accessing the nth element of an array and for accessing a field. I always forget to use, for accessing the fields, to use this single quote characters here. But let's try it out. We have here our users, and A is 6, and I want to access the A value. So give me the name and GUI A. This is converting JSON into text values. This would give me also 6, but this 6 has now the data type JSONB. We see it is very small, and especially when you access string values, you see that there are double quotes here because this is a JSON string and not a varchar. And don't try to use search and replace to replace those double quote characters and so on. The error is the error. The error is the error. So now it is a native PostgreSQL string. Now you see it returns a text and not a JSONB. Okay, what I wanted to tell you, these single quotes are important because now it looks in the column name what's there. There's Peter, and now it looks in the field Peter. So it's actually an attribute dereference. But there is no field Peter. And if we want to access array, the column A does not exist. So it is important to write double quote characters here, otherwise it evaluates the this column expression. Okay, these were these 4 operators for accessing an element in an array or an element in a text. If you have an array, you can check whether it contains a specific value, or if you have an object, you can check whether it contains a specific field. So instead of using this arrow now, we can check, is there an A field? Yes. For this row, Peter, there is an A field, and for this row, Jane, there is not an A field. So we can again print our JSON data, and it checks whether the field is present or not. So this is the question mark. And if this would be an array, then it checks, does it contain, so here, does this JSON array contain the value yoga or not? This is very nice. But mind that this does not support indexes. So we will later see how to support indexes here. I like this operation here because you can do this you can use this operator for so many things. It is called the containment operator. Does the left JSON data contain something from the right JSON data? So in our example, I have my GUI and A is 6, and I ask, does GUI contain? And now this is kind of what we call a query by example. We give an example that would be true, but everything that is more than that example, so if we give an example with an array with 5 elements, it is also true if there are additional elements. Or if we give an example document with 5 fields, it also is true when it has additional fields. So we will give now A is 6, and it matches to true for this document here, because yes, A is 6 is part of this document. That here is also a name and so on is not so important. It is part of that. And why is this so, why do I like this operator? Because it's so universal. You can use it for so many things. For example, you don't need AND for checking whether A is 6 and name is Peter. You simply put both conditions within your example here. And yes, this is the case. If you have an array, let's say we add a user called Julia, and we put here A is an array of 1, 2, 3, 4, 5. Then we can check, does this array called A contain the value 5? Yes, this is the case for that one here. Does it contain 5 and 4? Yes. Does it contain 5 and 4 and 9? No. Okay, this is a very nice universal operator to check whether a sub JSON is part of the super JSON. And especially when you combine multiple predicates, it is more efficient than using multiple times something like this. Because here SQL, so where did I have my my combined query? It was here, A is 6 and name is Peter. The alternative would be putting this in an AND condition, something like this. Then again, it's part of it's SQL's job to compute this and compute that, and if both is the case, then true is returned. And now it's the job of the JSON evaluator to check whether the whole condition is true or false. Okay, if you have something like an AND here, PostgreSQL is so smart, so if this is false, then it will not check whether this is true or false, because the whole AND conjunction here can never be true. So there is optimization going on, but nevertheless, it's always the better approach to do everything with as less commands as possible. Okay, there are now multiple questions in the chat. Let me take a look in the chat. Is there a way to not only check for the well-formedness, but also if JSON is valid? Yeah, we talked about validity and well-formedness. Well-formedness is just syntactically correct. Is every box bracket that is opening again closing? Is every double quote character again closing, and so on? This is well-formedness. And validity you can only check when you have a schema. I don't know whether relational database management systems support JSON schemas. Let's check this. We saw in, what was it, in MySQL? Yeah, in MariaDB there was the function JSON valid. So they check whether a JSON is well formed with a function called JSON valid. So this is a bad name for the function, but well-formedness and validity is often misused, the words. So actually it does not check for validity but well-formedness. But let's say PostgreSQL JSON schema. I searched for this already in the past. There's a PostgreSQL extension, and then yeah, I don't really know if it is natively supported. So I would recommend to do the schema check either on application side, or create a user-defined function that does this. I don't know whether relational database systems natively support JSON schema check. For XML, yes. For XML, there is the SQL standard, which says you can specify in the column definition, here where you say hobbies is of type XML, that you can directly provide the path or the URL to a XML schema, and only that documents that match the schema are accepted, but for JSON I did not see this yet. Then there was another question. Let me quickly open the other chat. But please specify this question further, because I don't know yet what it relates to. Is the same syntax also available for querying XML columns? There are a lot of similarities between the SQL XML and SQL JSON standard. You use XPath, here you use JSON path. You use XPath exists and then JSON exists and so on. And there are functions to create or build XML data. It's called then XML arc for the aggregation function, or XML element for creating a new element and so on. So there are very many similarities. And the reason for this is because JSON and XML models the same things basically, or similar things. And there was the SQL XML standard, and the people had this in mind. There is already a standard, let's make it in a similar way as there, to not invent the wheel from scratch. Does this answer this question? I see. Can you do something like hobbies foo0 for XML? Yeah, this arrow things, these are part of PostgreSQL's implementation for JSON. And I think when this was implemented, there were smart people sitting on a table and said, let's now implement it how we want to use it later. And the XML feature of PostgreSQL is closer to the SQL standard. So there it is not possible to use arrows and so on. Okay, so let's not do this quiz yet, because I want to show you another operator, and then we are almost finished with more operators. This operator @? So on the question mark you always see this is something that is returning true or false. Is it the case, yes or not? And the @? takes a JSON path. So far we did not see JSON path in PostgreSQL yet. So far everything was an SQL specific syntax for accessing or checking JSON fields. Now we can write a JSON path expression after @? and it returns true or false when it finds something or not. So you know this already. It is an alias. This operator is an alias for JSONB path exists. This exists simply says true or false whether we find something or not. We saw this on the slide where we did the example in Oracle. So how it is specified in the SQL standard. Yeah, in PostgreSQL they said, okay, we introduce another operator for this, for writing, okay, the JSON field, and then checking whether this path expression here returns something or not. So we go into the document, into the subfield hobbies, and check whether an element in that hobbies array is yoga. And this is the equivalent to this. We can not only use path queries to check whether it finds something or not. You can also use path query. I'm not disturbing here. You can also use path queries like we saw in JSON value, the function. That was this function here. JSON value takes a JSON and a path expression and returns the result. And you can do this in PostgreSQL with JSONB path query. You provide JSON data and a query, and this query can now be complex. So I want only those elements in the array that have a sub document with the field currency and that has the value euro and so on. If you have an array of prices and I want only those which have the currency euro or so on. So then you can filter directly on the JSON and this query gives you back the result. The easiest is when this JSON path only returns one thing. So let's try this out. So select JSONB path query and I provide a JSON here. So A is 5. And then I provide the path. So $A. It gives me 5. And now let's say it is an array with 5 and 10. Now it returns the array. So the result of this is always JSONB. But if I unnest this array, you see, no, you don't see, now you see, or if I increase my pane here, then you see it returns multiple rows now. This is very strange, right? So that a function returns multiple rows, and let's say I want another column with hello, then this hello appears in everything. This is called a set in PostgreSQL. You can also use queries that return a set of values in the from clause. Select star from this query here. I like this because from has tables and select, in my opinion, only has scalar values. So if I know that this query would return multiple results, like here this query returns all elements in the given array, I would recommend you to use this in the from clause. Okay, this is much simpler. There is only one first hobby for every person, and we access this first hobby and return it. Now I ask you, which expression is equivalent to this one here? Go to frage.de, Frage with 2a, and please answer the question, what's equivalent, which expression is equivalent to that one here? The query hobbies 0. Does the link work? Frage.de? Or do I need to refresh? Yeah, it should work. Okay, 21 people answered. I will show you the solution. The solution. So these ones here make no sense, because after you convert something into a text, you cannot continue with JSON operators here anymore. And here, does it return a JSON? That would be a difference here. Or does it return a text? Let me see. This JSON path query here returns a JSONB. So actually, I need to check this. I would say the green ones are more right here, because the result is the first hobby, but not as a varchar, but as a JSON. But yeah, for both the green and the red ones are basically correct, because it's hard to distinguish now. Only the result type is different. I would recommend this syntax here when you write such a query, so that you don't have a JSON as a result, but the hobby as a text. Okay, now I show you this slide about the thing that I just showed to you for unnesting data. And unnesting means you have either a path expression that matches multiple times within a JSON. Then we saw it returns multiple rows. So for each match, it returns the matching value. So we access the first element in the hobbies array, the second one, and so on. So many elements which are in the array, so many rows are returned here. This is just an alias for the table. So I call this table people. I don't give it an alias. You could say people P or something. And here I say this table I call hobbies, and the one column is called hobby. The same is also possible with a built-in function, or there are many built-in functions. So you can Google PostgreSQL JSON functions and operators here. So here are all operators and so many functions. JSON each to iterate over all keys of a JSON field. We need here to iterate or to unnest the elements in an array. There is JSONB array elements. It gives you all elements, and the result is a set of JSON again. And if you know that there are texts in this element, you can use JSONB element text so that you get it back as text data. This is unnesting here. Okay. We will talk about indexes the next time. Just for now, it is possible to create an index on JSON data. I know only PostgreSQL that supports a so-called GIN index, or not GIN index, but just GIN, generalized inverted index. This is an index that stores every field in the JSON document and the value to quickly find something. For example, who lives in Berlin? This query here can use the index, because city Berlin is stored in the index like a tree. There we store city Berlin, and then an arrow, a pointer to the row where the person has city Berlin in the JSON field. Okay, we will take a look at this next time, how the indexes are used, how you can create them. There's already an exercise about that. So I will upload an exercise sheet now. And for those who already downloaded this PDF last week or so, I uploaded a new version because there was an error with the index slides here. So take a look on these slides for this JSON indexes. You create a GIN. We will next time look how they internally work, and we will take a look at an alternative to a GIN index, because you can also use an expression index. This is just a normal index. You can say I create an index, create index, my index on the column users, on the column name. This is has nothing to do with JSON. This is possible. This is just a normal index. But you can also say I want that the expression is in the indexized. So I drop it again, drop index, my index, and I store the uppercase of every name into the index. So when I insert a person called Peter in the index, the uppercase format of that person is there, and it supports me when I say give me all people where upper name equals Peter. There now the index can be used. This is an expression index. The result of an expression is stored in the tree, and we can use it for storing the result of a JSON path expression or JSON expression here, this operation, to store the city values, and city is a field in a JSON column, into a normal B+ tree. This is one possibility. This is all you need for the exercise. More details about indexes we look at next week. And now I quickly take a look at the questions. There are some questions in the array in the chat. Is there a way to use the add arrow operator and require elements in a list to have the same order? It is added. There is no order. So this was the containment check, where we check A must be 5 and B must be 7. But as the order of fields in JSON is not, there is no order, the order does not matter. So you cannot check whether the order is right. But you mean the order in an array, right? So you have an array of multiple values, and I used this I used the query here, whether it contains 2, 3, and 5, and so on. I don't think that this works. How did I do that? From users where GUI contains the A array with 1, 2, 3. This works. Yes, but 1, 3, 2, yeah, it also works. So you cannot specify that this preserves the order. Maybe there's a flag or something, a magic one to enforce that this is checked, but yeah, this is not checked with this operator. Basically, do a tree-like schema as JSON with enters and no. You are too close to XML. These things are more flexible in JSON. JSON is less strict. Okay, do you have other questions? An array is an ordered sequence of 0 or more values, exactly. Okay, then we are finished for today. Next time we take a look at indexes, and then we open a new chapter about NoSQL databases to see similarities and differences, a quick overview of a multiple NoSQL databases. Okay, then thank you very much and see you next week. week, or see you at the exercise slots. The exercise will be available in 1 minute. See you, goodbye.